This is Chemistry Unit 13, Solutions. Dilution. In order to save space in a laboratory, chemists generally buy concentrated solutions, and we call these stock solutions. So when we want a particular concentration of a solution for a lab, for example, water is added to the concentrated solution in order to reach the desired concentration. So for example, common concentrations of concentrated acids are sulfuric acid, which is H2SO4, and it's commonly 18 molar, nitric acid, which is HNO3, it's commonly 16 molar, and then hydrochloric acid is HCl, and that's commonly 12.5 molar. Okay. And if you are ever working in a lab or ever having to deal with acids and having to dilute them, which most of your teachers have to do this quite regularly, there is a little rule that you need to follow. You always want to add the acid to the water when you are diluting it. So when the acid goes in, it's an instant dilution. If you reverse that, it might spurt out. The water might not combine with the acid very quickly, and it might spurt and get on your skin. So it's always add acid to water if you are ever in a situation where you are asked to make a diluted solution. In any case, the process of adding more solvent to a concentrated solution is called dilution. A dilution problem typically involves determining how much water must be added to an amount of stock solution to obtain a solution of the desired concentration, which is what your teachers need to do when they're prepping your labs, right? You will never be working with a stock solution that is too dangerous. You'll always need some diluted acid or base. So dilution means to add water to that acid, right? So it's not as dangerous to use. Now there are two things to remember about dilution. The number of moles of stock solution does not change, and only solvent is added in the dilution, which is typically water. Okay, so let's in particular look at this first part. Like, what does this mean that the number of moles does not change? Well, in order to perform the calculation, the number of moles needs to be solved for since it's going to remain the same. And we're getting this from our molarity equation. So if capital M, if molarity equals mole per liter, we can also say that that means mole per volume. So I just rewrote volume instead of liter. Okay. So therefore, if we solve for mole, which should look familiar from our molarity calculations, if you want mole by itself, that means it's molarity times volume. So this number of moles that is desired is not going to change when we're solving for dilutions. Okay, we're not there yet, but I'm just trying to show you how this is derived. All right, so if we want the final amount and concentration of a solution to be a certain value, so from that stock solution, you want a final amount and a concentration. We call this M2, which is the molarity after the dilution that students will eventually use, for example, and then V2 is the volume after the dilution. So how much do I need to make for a particular class, for example? Okay. Now, if we have the initial concentration and amount of the stock solution at a certain value, then that's M1, right? That's the molarity before the dilution. That's the stock solution that we have on hand. And if that's our stock solution, we will know its molarity. We will also have V1, which is the volume before the dilution. We know how much we're going to have. So if we put this together, right, if our moles is going to stay the same, and from back here, right, we knew that M times volume equals mole. So we don't need the moles now. So what I'm doing now is I'm putting this M and this V together. So this is before the dilution and after the dilution. So it's M1 V1 equals M2 V2. It's our molarity and our volume before the dilution and our molarity and our volume after the dilution. Okay, so let's see what this means. Okay, so what volume of 16 molar sulfuric acid must be used to prepare 1.5 liters of 0.10 molar sulfuric acid? So right here, this 1.5 liter, That's how much a teacher would need for like a class lab, right? They need 1.5 liters of a very much diluted sulfuric acid. 0.10 molar sulfuric acid is diluted quite a bit. How do I know this? Look at that original concentration. 16 molar is pretty strong. You don't want to touch this stuff with your bare hands. But nonetheless, if you've got the 16 molar on hand, how much of that do you need to be able to make this diluted solution? So let's check out what our M1V1, M2V2 are, and which one is missing, which piece of that has not been provided. So this is our formula for dilution. And now what do we have? This 16 molar is our stock solution. That's our M1. That's what we have on hand. We are trying to get that down to 0.10 molar sulfuric acid for our lab, and I would need 1.5 liters for a lab, for example, right? So how much of this do I need now to make this happen, right? So what you do is you multiply. So the 16 molar stays the same, the V1 stays the same, but 0.10 times 1.5 is 0.15, and it's not milliliter, this is mole per liter, okay? I did not write that wrong. These units have not canceled. So now V1 must be 0.15 molarity times volume divided by that 16 molar. So your molarities cancel out and you are left with 0.0094 liters. So what this is really telling you is how much of this really strong acid you need in order to make this dilute solution. This isn't the amount of water that you're adding. This is how much of that stock solution you need to create that dilution. So it's a very tiny amount. So you're going to need a lot more water than acid, right? Because it is supposed to be dilute. All right, let's check out another example. All right, so here it says calculate the new molarity when 25.2 milliliters of 14.9 molar nitric acid is diluted to 1.00 liter. So right now you've got the stock solution, 14.9 molar nitric acid, and you know how much of that you need for your dilution, 25.2 milliliters. So again, these are tiny amounts. They're supposed to be. But you want this diluted to 1.00 liter. What strength is that? Okay, so our equation does not change, but the parts of it that we have do change. And you have to be careful with this 25.2 milliliter. You need to solve in liters. Okay, molarity is always in liter. All right, so my stock solution is 14.9 molar. Notice what I have here. You take 25.2 and divide it by 1,000, and you get 0.0252 liter equals, we were trying to figure out the new molarity. So it says calculate the new molarity, that's M2, and we know that we need 1.00 liters of it. So you will multiply 14.9 times 0.0252. This is not milliliter, this is molarity times liter, and it equals M2, which has not changed, and the 1 liter has not changed. Okay. Now, what do you do next? Well, you're trying to get M2 by itself. That's what you're trying to solve for. So you need to divide by 1, which is a great calculation because it ends up being 1. And your significant figures are both the same, so you should have 3 in your answer.